SLR1 parsing. For LR0 and SLR1, we are going to use LR0 items. And for CLR and LALR, we are going to use LR1 canonical items. So SLR parsing works on smallest class of grammar. Few number of states are required. Simple and fast construction. In SLR, we place the reduce move only in the follow of left hand side, not to the entire row. In LR0, we are placing the reduce move in all the terminals. Whereas in SLR1, I already told you, in LR parsers, there will be a difference in the parsing table only. Remaining stack, input and action, everything will be same. Only in the parsing table there will be a slight difference. So in SLR we need to place the reduce move only in the left hand side, only in the follow of left hand side. So with this example you can understand clearly. So the example is A tends to AA. So first you need to consider, the first step is write the augmented production. So the augmented production is A dash tends to A, and write the remaining productions A tends to A tends to A. And the second step is write the LR0 canonical items. So LR0 canonical items is nothing but placing dot on the placing dot before the first production in the right hand side. Okay, so to the right hand side we need to place the dot, that is it becomes as A dash tends to dot A tends to dot of A tends to dot A. Okay, now construct a data flow diagram. A dash tends to dot A tends to dot A tends to dot A. So this I am considering as state I naught. Now we need to move the states, like what is data flow diagram is nothing but the dot which is placed on the starting of the right hand side, starting of the right hand side production, that should be placed to the last of the right hand side symbol. In that way you need to construct the data flow diagram. So now I naught on symbol I naught on symbol A, so it becomes as A dash tends to A dot, this dot should be shifted, so then it will become as A dash tends to A dot, then this is considered as state I1. Now a on symbol left parenthesis, so it will be changing as A tends to left parenthesis dot A right parenthesis. So after dot, if we have a non-terminal, then we need to write all the productions of that non-terminal. So the non-terminal, for this we have productions like A tends to dot A and A tends to A, so that also you need to write here, and this I am considering as state I2. Next, I naught on symbol A, so it will be changing as A tends to A dot, so this I am considering as state I3. Now again, so whatever we have in this I naught state, all the symbols are being completed. Okay, now check whether this dot has been placed to the end of all the productions or not. So in I1 state it is been completely done. Now I2 state, so this we need to shift, that is on state A, so it will be changing as A tends to left parenthesis A dot right parenthesis, so this is considered as state I4. Now again still it is not moved to the end, so again you need to move to the end, then on right parenthesis we are performing the operation I4 on symbol right parenthesis A tends to left parenthesis A right parenthesis dot, so this is considered as state I5. So this B is been completely moved to the last side of the dot is being placed to last of the right hand side production. Now this is been completely done. Now coming to this production, A tends to dot of left parenthesis A right parenthesis. So it will be changed as A tends to left parenthesis dot A right parenthesis, though this is already there in this same state. So that is the reason I am drawing a self loop here. And again this is there, we have A tends to dot A. So this will be changed as A tends to A dot. It is there in state I3. So I have drawn a transition to state I3. So with this all the symbols have been completed. Now you need to construct the parsing table. So in the parsing table we are going to consider the state, action and go to. In state you need to write all these states from I naught. How many states we have considered, that we need to write here: I naught, I1, I2, I3, I4 and I5. And in action we need to consider all the terminals. The terminals which we have here are A left parenthesis, right parenthesis and dollar. In go to you need to write all the non-terminals. So non-terminals here we have only capital A. So non-terminals we have only capital A, that we need to write in go to. Now check here, 0 on A, 0 on A, 0 on A, what we have? Now check here, 0 on symbol A. 0 on A we have, it is moving to state I3. So here in action we are going to consider as shift. So for shift we are denoting it as S. So 0 on A, it is moving to 3, state 3. So we have written here as S3. And 0 on left parenthesis, 0 I naught, that is 0 state on left parenthesis, it is moving to I2. That's the reason I have written as S2. And 0 on right parenthesis and dollar, we don't have anything, I didn't write anything. Now I1 on I1 state on, we don't have anything here. So I1 on dollar we need to write as accept, it is mandatory. I1 on dollar, that is I1 state is nothing but the augmented production grammar. So wherever the augmented production is grammar is there, for that on dollar you need to write as accept. Next 2 on A, that is state I2 on A, I2 on small a, it is moving to state I3, you need to write S3. 2 on left parenthesis, 2 on left parenthesis, the self loop, that is you need to write S2. And 2 on capital A, 2 on capital A, 4. So in go to you need to write only the number, so 4 we need to write. And next 3 on right parenthesis, 3 on right parenthesis, 3 on right parenthesis, it is nothing but the end state. So we don't have, it is not moving anywhere. So for that what we need to do, we have to consider the productions and the number it. So this is the first production, that is A tends to A, this is first production, and A tends to A, this is second one, this is called as R1 and this is called as R2. Okay, so I3 state we have A tends to A, that means R2. So where we need to write this R2, you need to write only to the follow of left hand side. So follow of A, so follow of A is what? So follow of A is what we have here, follow of A, right parenthesis, follow of A, what we have, right parenthesis, and A is the starting symbol. For A was the starting symbol, dollar is also comes under follow. So follow of A is nothing but right parenthesis and dollar. So in place of right parenthesis and dollar you need to place R2. Next 4 on right parenthesis, 4 on right parenthesis, it is moving to state I5. So I have written as S5. And 5 on right parenthesis. So first consider state I5. So I5 is the end state. There is no shift operation performed here. Only the reduce can be performed. So for that what we need to write, A tends to A. It is R1, that is reduce 1. So where we need to place the reduce, in follow of that operation. So follow of A is nothing but right parenthesis and dollar. So in place of right parenthesis and dollar you are going to place R1. This is how we are going to construct the parsing table. Now we need to parse the given input string. So the given input string is left parenthesis, right parenthesis, left parenthesis, A, right parenthesis and dollar. So parse the given input string, stack, input and action. So in the stack you need to consider dollar, input, consider this input, and after the input you need to place dollar. Now in the stack consider 0, like 0 is the starting symbol. Now 0 on left parenthesis, see in the table, 0 on left parenthesis, 0 on left parenthesis, S2. So right here S2, S is nothing but shift 2. Okay, so this left parenthesis and 2, clear, shift left parenthesis 2, that is being shifted here. Next, whatever remaining is there, that we need to write here. Now again consider 2 on A, 2 on A, check this from this table, 2 on A, shift 3. So shift 3, shift, what we need to shift here, A3, shift A3. So $0 to A3. And now what we need to do, 3 on right parenthesis, 3 on right parenthesis, check this, 3 on right parenthesis, reduce 2. So in reduce 2 what we have, A tends to A. So reduce R to A tends to A. So in place of this you are going to place A. In place of A we are going to place A, and here you need to get the number. How you will get the number? This you need to consider, 2 on A. 2 on A what we have, check here, 2 on A, 4. So write here 4. Now 4 on right parenthesis, 4 on right parenthesis, shift 5. So shift 5, what we need to shift here, this right parenthesis, shift this right parenthesis. So this has been dollar, reduced to dollar here. Now 5 on dollar, check here, 5 on dollar, 5 on dollar, R1. R1 is nothing but A tends to A. So A tends to A. So this A is being reduced with A. A is being reduced with A. So now 0 on A. 0 on A. 1. So now here I have written 1. 1 on dollar. So 1 on dollar is accept. So our finally the input string is accepted. And next you need to construct the parse tree, that is A tends to left parenthesis A, right parenthesis, and A tends to A. So we got the given input string. Mama. So in SLR, reduced is written based on follow function, whereas in LR, follow we place on all the terminals, whereas in SLR we place the reduce only in the follow function.